Hey Joe, I'm going to go through the example you emailed about. I don't know which PLC you're using, but I've got an ACE 222 sitting right here next to me, so I'm going to go ahead and use that. Feel free to just use this hardware setup tool to change whichever one you're using. Um, okay, so first off, we talked this morning about using the scale in order to make the input value more meaningful, and we'll create something called out in volts, and we'll go from 0. You've got a 0 to 5 volt input, I believe, is what we talked about. So we'll say 0 is equal to 0 and 4095 is equal to 5, and we made sure it's a floating point value so we have decimal points involved. And what you want to do is turn an output on for 10 seconds whenever the input goes above a certain voltage threshold. So let's say that we'll make a little state machine here, like we always do. Let's see here. We'll put a 1 into state. And I'm going to have that be the actual first thing that happens. And then we go into our scale, which we're going to do all the time. We're going to ask if state is equal to 1. If so, we're going to be checking for the analog value to be greater than some threshold, and out in volts we'll say is greater than, hypothetically, we'll just use 3.2 volts. If so, we'll do a couple things. We're going to be starting a timer in this. Will also be, we want to reset the timer, and we want to turn on an output, because that's what you want to do. You want to turn on the output for 10 seconds. So we'll pick, we'll put the value, we'll advance the state to 2, and then we will put a 1 in an output. We'll use D1 in this case. So that's what we'll turn on for 10 seconds. And then we'll also clear the timer, so it's starting over again. My timer. And I'm keeping everything kind of scrunched up here just so everything can stay on the screen. Okay, in state equals 2. Okay, so we need to handle the no path here. So as long as it's the voltage is not greater than 3.2 volts, it's just going to hang out in the state equals 1. Once it is, it'll advance to state equals 2, and we'll be doing this. And we're going to ask, is the timer greater than 10 seconds? If it is, we will move it to state equals 1. We'll put a 0 in the output, and we don't have to do anything with the timer. Okay. And if it's less than 10 seconds, it's just going to hang out in the state equals 2. And I'll do that indefinitely. I've got a... Oh, wait. I made one mistake here. You'll see I need to make sure that our scale is inside the loop here so that its value is being updated each scan. If I had it like I did, if I left it like I did, this would have only operated the very first time through, and then it would be stuck in a loop where it was never executed again. So I need to be sure to do that. Okay, so I've got this running. Let me check what's going on here. Okay, see I'm twisting a knob on analog input, and you can see it's cruising up there. And once we I'm going to hold off here for just a second while I explain. You'll see the output bit is located right here, and when I turn it back to value, you'll see it's a 0 right now. Once I twist this above the 3.2, you'll see this turn to a 1, which it did, and it's going to hang out there. I'm going to turn it back down, so it'll hang out there for 10 seconds. You see it counting up 7, 8, 9, and then it's going to turn to 0. There we go. Okay, so if I do it again, you see it's on and it's doing a count for 10 seconds. After that happens, I'll put a breakpoint here actually, so you'll see it run into this. There it is. It hit that breakpoint, and if I step through once, you'll see the output here turn off, and it did. That does what you're looking for.